3.4. Average rate of change. Your test on Thursday is over 3132, 3334. I have your quizzes. If you don't have them, we'll grab them before you leave, the 3132 stuff. But I have a review that I will do with you guys on Wednesday in class. But average rate of change is just a fancy way of saying slope. Okay, slope we talk about with linear equations. Which is y equals mx plus b. Average rate of change you can use with any function, linear, quadratic, cubic, anything like that. But all it is a slope formula. What goes on top? Look at the formula, right? Y goes on top, and what goes on the bottom? X, okay? It's y minus y over x minus x. So if you have something like this, if it tells you on a picture or a graph to find the average rate of change from the graph, do you guys see where they're talking about? They want the average rate of change along this dotted line. Does everybody see that? So what point, we read left to right, what point are we starting at on the left-hand side?
0, 6.
It's at 0, 6. Agreed? 0, positive 6. You guys agree with me? What is the point on the right-hand side? 5, 2. So to find the average rate of change, what formula do we use? We use the slope formula. So what am I going to do? What goes on top? So 6 minus 2. We have our x's and our y's, right? So it's y over x. So 6 minus 2 over what? 0 minus 5. So I have, what's 6 minus 2? 4 over negative 5. That is your average rate of change. It's super easy. But you just find the points and do slope. How did I know at the beginning that my answer was going to be negative?
Because
It's going down, right? We always read a graph right to left. You can count. You can count.
Every time
It's not always going to be a line, though. Like, we're going to talk about parabolas and stuff like that. Yeah.
It's always going to show us the 2 points.
No, not always. Not always. Let me go through some examples and then we'll look at it. If you have something like this, average rate of change from given values. I know that doesn't mean anything to you guys right now. If you look here, if they say find the average rate of change for the following, they're telling you what to use for x. Yes? So when you plug that in, what value are you getting? When I plug in something for x, what is f of x? It's a fancy way of saying what? Y. So you can do this. You can look at this and say, okay, my first point is going to be 1 comma something, right? My second point is going to be 3 comma something. You guys with me? You understand what I mean by that? So if I say I'm going to plug in, let's plug in 1. So I have 2 times 1 minus 1. What's 2 times 1? 2. And 2 minus 1 is 1. So when I plug in positive 1, I get out positive 1. Agree? Okay, so now let's do the second one. Let's plug in 3. So I have 2 times 3 minus 1. So 2 times 3 is 6 minus 1 is... So when I plug in 3, I get out what number? 5. Now, how can we find the average rate of change? Find the slope. Use the slope formula. So I'm going to say... You guys want to say 5 minus 1. Okay, so then it's what? 3 minus 1. What's 5 minus 1?
4
over
2.
Which becomes 2.
Are we gonna have to be able to show on a graph what this looks like, or do we just have to be able to find?
You're going to recognize from a graph or from a table, but you're not going to graph anything.
So it's gonna we have options.
Something like this.
Okay.
So 5 and 1 were the y's?
Yeah, when you plug in, whatever you plug in for x, you get out a y value. So if you have something like this, guys, this is a word problem, this is a graph, okay, I get that. But all this is saying is telling you what the graph is representing. They want to know the average rate of change between what two numbers? 100 and 200. So I'm going to write my points. 100 is one of the x's, and what's the other x? 200. So on your graph, go to the 100. Everybody see where x is 100? What is the y value there?
75.
So it's 175. You guys see that? And then at 200, what is the y value? 50. Do you see now how you have your ordered pair? that's not a straight line, so you're not actually finding the quote-unquote slope. You're finding the average rate of change, which uses the slope formula. So we're going to say this is x, this is y. So what am I going to put?
75
You guys want to say 75 minus 50? Okay. Then what goes on the bottom? 100 minus 200. So what's 75 minus 50? 25 over what? Negative 100. Okay. Can we simplify that? It's negative what? 1 over 4. Good. Very good.
You have to simplify.
Yeah. Say your fraction came out to like 7 over 94. Can you simplify that? No. So you just leave it. But if you can simplify, go ahead and do that. We good? We okay? All right. Next one. All right. What's the average rate of change over the population between 98 and 2001? What's the average rate of change between 2000 and 2004? All right, you're just reading a graph. That's it. What is your x? This is in an xy form, right? What is your x value? The years of the population. Okay. This is my x and population is y. So they want to know the average rate of change for letter A. They want to know the average rate of change between 98 and 2001. So in the year 1998, watch, I'm going to write 1998. That's my x value. What was the y value in 98?
856.
856. Perfect. And then my other one is 2001. So in 2001, what was the y value? 1591. There's your x. There's your y. Correct? You guys with me? Okay, so what goes on top?
159.
1591 minus what?
856.
856 over
2001.
2001 over
1990.
1998. So, what's 1591 minus 856? All right, so 735 over, Ryan, what was the bottom you said?
3.
3. Does 735 divide by 3?
Yeah,
How do you know?
because it's 7, 35 in it. 3 goes into the bottom.
Okay. No.
245.
Oh, wait, I'm sure. Plus the bottom.
But look, add up the digits. What's 7 plus 3? 10 plus 5.
15.
Does 3 go into 15?
Yeah.
That means 3 will go into 735. So when you divide it, what do you get?
245.
245. Okay. So then we're going to do the same thing, but between which two time periods?
2002, 2004.
Okay, so in 2002, look, here's my 2002, and then you said 2004.
Yeah.
Okay, what was the population in 2002? 1483.
Yeah.
And then what was the population in 2004? 826.
Yeah.
So here's my x, here's my y. What goes on top?
14.
All right, you want to do 1483 minus what?
26.
826.
657.
All right, and then what's on the bottom?
2002 minus
2002 minus
2004.
2004. So what's 1483 minus 826?
657.
657
Mm-hmm.
over what?
-2.
Negative 2. All right, does that divide pretty? No, so just leave it. But all you're doing, guys, you'll be given a table, you'll be given a graph, something like that. Just identify the point. So see, Hayden, how they didn't explicitly give you the point, but they're giving you the point by the table with an XY chart. Does that make sense, guys?
Will you ever get a graph without any points?
No. No, I'll make sure that you have something that you can physically see. All right, there's one more thing I want to talk about. We kind of touched on it last week, but let's just look at this. We talked about relative maximum and minimums, yes? When we talk about intervals of increase and decrease, where do we look for intervals of increase and decrease? What axis?
Y.
Nope. X, right? Intervals of increase and decrease is on the X. We'll talk about that more. If you have an interval of increase and decrease, it's always the X axis. I'm going to say that a million times. When we talk about maximums and minimums, maximum is how high, a minimum is how low, right? What axis do we look at if we're talking about how high something is or how low something is?
Y.
The Y. So you'll have a picture on your test. It might look like this. Or right? You see those two graphs?
Auburn.
I didn't even mean to do that. Good job. Wasn't even thinking. Oh, Borja, you're just precious. War Eagle. Maximum or minimum? The first graph on the left. Does that have a maximum or a minimum?
Max.
Right here. What is this? Is that the highest point of the graph or is it the lowest?
Maximum.
It's the highest. So you would say that there's a maximum at y equals, and then whatever the y is. Say it's a 6. So y equals 6. I don't care about the x-axis. This one has a what?
Minimum.
You would tell me it's a minimum at y equals, say it's -3, whatever. But I'll give you a graph where you can actually physically find the point, you can put your finger on it, and you're going to have to tell me whether it's a maximum or a minimum, and you have to tell me it's at y equals, whatever the y part is. That's all I care about. All right?
When's the quiz?
We have a test on Thursday, over 3-1 to 3-4.